Achal, Priyanka, Ashish, Sunil, Darshan, Venkatesh, Hemant, yeah, all of you. Good afternoon. Chalo, we'll continue from last topic. I will revise. So these are topics I'm sure many of you have heard about them or you have read in your GS classes. What happens is, I'm not saying it's right or wrong, क्या पढ़ाया जा रहा है, but lot of concepts of yours are clashing. You have heard something, you have read something, and then I'm saying something. ठीक है, so वो सब खिचड़ी हो जा रहा है आप लोग का. So my suggestion is कि आपने जो पढ़ा है उसको थोड़ा साइड रख लो. I finished this topic, I revised it for you, you make your notes, then go back and see whatever you have read somewhere. और उसको करेक्ट कर लेना अगर एरर्स हैं या जो भी हैं. एंड देन यू हैव सम इश्यूज आस्क मी. ठीक है. अभिरूप, व्हाट वाज योर डाउट इन व्हाट्स, बताओ क्या डाउट है. हाय निधि, महक, गुड आफ्टरनून. Okay, Hemant. See, I have told this repeatedly. NCERT books are important, but if you start with NCERT books for geography, then you are in trouble. Only for geography. Otherwise, NCERT history, NCERT sociology, NCERT economy, NCERT polity, civics, all of them are very well written. Okay, I mean, having read quite a bit, so I think they're very nice. Even geography is nice, but geography and CRTs you can appreciate once your coverage in the class is done. Okay, इसीलिए मैं कह रहा हूँ कि मेरे साथ पढ़ो. Okay, only one chapter, 2 chapters. ठीक है. So read NCERTs along with the class, not beforehand, is my suggestion. And that's why when students are studying on their own, I'm a bit reluctant starting geography from NCERTs. NCERTs 6th, 7th, 8th ठीक है, but NCERTs 11th, 12th are fairly deep, but details are missing. वो बस एक sentence बना के छोड़ देंगे, and then you're wondering ये कहाँ से आया, what are the concepts. Okay, so that becomes an issue. Abhiroop, I continue to ignore your doubt. You have to wait for some more time. Let me enter that domain, then I'll discuss. Okay, you're going to rock cycle and the igneous rocks. I have not gone that far. So wait for some time. I'll come back on that. Yes, Nikhil, I got that doubt of yours also. I'll explain it now in the class. The question asking me was, sir, how can Pacific Ocean have subduction in both the sides? Okay, so it's like this. The mantle cells, they can be across oceans. What I mean by this is, so typically how I draw continent here. I have drawn say ocean here, and a very simple diagram is a rising limb here and a subducting limb here, a rising limb here and a subducting limb here. इसमें क्या हुआ? The ocean continent के जो margin है, this is where we have subduction. Okay, so here this becomes one plate, this becomes another plate, this becomes a third plate, and this margin के बाद में this becomes another plate. This is a very simple diagram. In reality, it need not be like this. Imagine this. So I have continent here, I have an ocean here. I have an ocean here. Okay. Then I have continent here. I have ocean here and again ocean here. So imagine a convection cell which probably rises here, okay, and maybe sinks here. Where this continent ocean is not the margin. This is what we call as passive margins. Okay, this is active margin. Active margin where I am having subduction of the ocean. यहाँ पर ऐसा नहीं है. Okay, imagine here I have a rising here पर and the subduction or the sinking happens here. Okay, then what happens? यहाँ से यहाँ तक ये एक ही प्लेट है, which is part continent, part ocean, okay, and this with maybe some divergence happening here, ये हो सकता है. So this is one plate, this can be one plate, this is one plate, and this whole thing is one plate. So the plates are not simple like this. Not every ocean content margin has a active boundary. This is not an active boundary here. Okay. So if I imagine this in case of Pacific Ocean, kar lo pehle. Just give me a minute here. I will add up some diagrams first. Hi Karan, good afternoon. Nikhil, I am answering your question. Just give me. अभिरूप, फिर आप आगे चले गए. अभी आप कुछ फैक्ट्स याद रखो. Okay, अभी फैक्ट्स ये बता रहे हैं. Okay, that hotspots is basaltic. By heart this for now. Why part? I'll come. कल से आप पूछ रहे हो, मैं कह रहा हूं. Hold on, I have not taught volcanism yet. I've just mentioned what are the volcanic events. Okay, as a part of tectonics. Okay, so give me some time, I'll enter that. Okay, so our discussion point here was that where subduction, where do we have mores, where can we have ocean or ocean continent. Don't see every ocean continent as a margin. Don't see that जहां भी ocean खत्म हो रहा होगा वहां पर सबडक्शन हो रहा है, वो जरूरी नहीं है. In case of North America, okay, the plate is North American plate, and the North American plate includes North American continent and a part of the Atlantic Ocean. वो पूरा एक plate है. Okay, so yeah, so come back here. This is say Kamchatka Peninsula, China, South China Sea, that's North America. Okay, so what's happening at the Pacific Ocean? The plate is, maybe I'll make it smaller. Okay, so the plate is this. This is the North American plate. ये पूरा plate है, which includes North American continent and part of the Atlantic Ocean. यहाँ पर this is the plate, entire Eurasia and also part of the Atlantic Ocean. Then the Pacific plate is something like this. I'm just approximating here. ये है Pacific plate. Okay. In the Pacific plate, इसके south में this is Antarctic plate, and this is a plate we have called as Nazca plate. ये प्लेट्स हैं. In this mechanism, this one is spreading boundary. यहां पर more है. The Pacific Ocean is pushed like this. It's going northwestwards. The Eurasian plate is going like this. The American plate is going like this. And this is where we have the Atlantic more. ये Atlantic more है यहां पर. Okay. If I draw here, this is the Atlantic more. Atlantic more here. Wherever we have mores, क्या होने वाला है? I have a push like this. I have a push like this. So in the Pacific Ocean, the push is from here. So North American plate moving like this. On this side, Eurasian plate moving like this. And this one here, because spreading boundary, the Pacific plate going like this. So that is how, okay, I have okay, subduction going on here. I have subduction going on here. And I have subduction in the north also. Can you all imagine here now? How is the Pacific Ocean behaving? The Eurasian plate is getting pushed like this. The American plate pushed like this. The Pacific plate is pushed northwards. Okay. The Eurasian plate from the more. This is the Atlantic more. This one is the Atlantic more system. This is the Atlantic more system. Wherever we have a more, there is ocean floor spreading happening. वहां से फैल रहा है. So while spreading out, ये ऐसे push होगा, ये इधर push होगा. I mean, this part is here actually. ये यूरेशिया है ना ये वाला. Okay. So from this side, I have this push. So this push is moving Eurasia like this. Okay. So Eurasia is going over Pacific Ocean. On this side, North America is going over the Pacific Ocean. That's how we have, okay, subduction here and subduction here. Then I said, yahan par more hai. Atlantic more is in the southern waters. Okay. Because of this, the Pacific Ocean is getting pushed northwards. That is how the convergence boundaries of Pacific are the western boundary, the northern boundary, and the eastern boundary. अब आपस में क्या डिस्कस कर रहे हो? अच्छा, you're teaching each other. Okay, fine. Okay, so this is the Pacific more. This is the Pacific more. Let me see if I have that diagram with me. Yeah, this will help. So this is the Atlantic more. Okay, Atlantic more here. ये पूरा एक plate है. This is one plate. This whole plate, because of Atlantic more, the push is like this. Okay. यहाँ पर south में, it's not showing here. This is the Pacific more. ये वाला part. Because Pacific more, the Pacific Ocean is pushed like this. Again, this part, this is getting pushed like this. That is how I have subduction here, I have subduction here, and I have subduction here. So the Pacific Ocean has a spreading boundary in the south. Southern Pacific में, you have this Pacific ridge system or the Pacific more system. All good, all of you here? Did I answer your question now? Okay, and then smaller ones are there. They say ये Philippines plate. This Philippines plate, okay, Pacific Ocean subduction here, and the Philippines is subducting like this. But यहाँ भी small plates हैं. There's Eurasian plate, there's the Amur plate here, there's a Siberian plate here. Okay, so they have become together a larger plate. So there are a lot of smaller plates also. Okay, and that's how the Pacific Ocean has dynamism along its coast. Shreyansh. Shreyansh is asking me about current affairs of geography. You always break my flow. Acha, theek hai. Current affairs in geography, I'll suggest you follow our Geography Current Affairs magazine. We are publishing every 15 days में. Okay, Cosmos के नाम से वो आपके वेबसाइट में फ्री है. Okay, you can follow that. You can follow Yuki also. Yuki also has geography, environment, current affairs put in place. And to give those articles to you, I am referring to all the resources that you're talking about. Down to Earth, the PIB, National Geographic, Hindu newspaper. I'm compiling it for you. Shreyansh. Anybody else here? So when I draw this Pacific Ocean diagram, so this is the Atlantic Ocean. This is the ocean part. Sorry, this is the Eurasian plate. The Eurasian plate. This is the ocean part of Eurasian plate. The Pacific Ocean subducting here, and the Pacific Ocean subducting here. And this is North American continent. This is the Atlantic Ocean part of the North American plate. This is North American plate. Okay. यहाँ से ये पूरा is the Eurasian plate, and this is your Pacific plate. So on the western side, this is ocean collision. On the eastern side, it is ocean continent collision. Ab theek hai, all of you? Yeah, so because of southern push, the Pacific Ocean subducts in the north also. That's how we have the Pacific Ring of Fire. Okay, so let me revise quickly for you. I was discussing ocean. आपको याद हो गया, I believe. Ocean will have a trench. Ocean will also have accretionary prism. There will be archipelago and volcanic islands. We will have 4-arc zone. Okay, the trench and the prism. This is part of the 4-arc. The archipelago is the arc, and then we have the back arc. Back arc will be a basin. It will be a marginal seas. Okay, so these are the features of ocean collision. Features of ocean continent. Okay, यहाँ पर trench होगा. Ocean continent will have massive accretionary prism that becomes the fold mountains, and we have called this as Cordillera type of mountains. They will have volcanism on the mountains, and the volcanism on the mountains will be andesitic eruptions. We also have intrusive magma, which is of the granite type, and this becomes the mountain cores. We have used a term, they become batholiths. They become batholiths. Okay, so this is the difference between ocean continent and ocean. Any questions on this? हाँ, बताओ. Yes. This granitic magma is formed at the OC boundary, and the CC boundary, they are there, but they don't have eruptions. Hoga? Okay. Every fold mountain must have started from an OC type. Okay. Whether Himalayas were once OC type. Okay. Urals were once OC type. Alps were once OC type. Okay. I have talked about sequence, remember? You start with OO, it becomes OC and then becomes CC. I will not have CC directly. अगर CC directly है, तो marine कहां से आया आपका? So for marine sediments, that area must have been ocean once upon a time. और अगर OC है, तो ये core बन रहा होगा. In the OC case, the core formation is the active formation, but in the CC case, a core बन चुका. The core is no longer forming, but it is there under the mountains. Okay, Trans-Himalayas, okay, were once OC type. When they're OC type, they will have volcanisms. Those volcanism rocks are now preserved in the Karakoram ranges. Okay, the volcanic rocks are preserved in some parts of Himalayas. Okay, answered your question? Anybody else here? Okay, so then we talked about the CC collisions. So this is the strongest compressive force. It will have enormous amount of sediments. They will have the highest mountain ranges. These are not volcanic, but they can preserve volcanic rocks of the past. Okay? Volcanism hai nahi. It's like, when I was a child, I was playing, I fell down, I hurt, I had a cut. As I've grown older, the cut mark remains. वो scar रह गया मेरे पास. Okay, but it is no longer an active cut. Okay, so the volcanism of the OC types can get preserved. Karakoram ranges have volcanic rocks. Himalayas have volcanic rocks. Shivaliks also have some volcanic rocks. Okay, the volcanic rocks are the remnants of the past volcanism. The remnants of past eruptions when Himalayas was the OC type. Okay, so they will preserve rocks of past volcanism, but these are seismic. They will be very powerful earthquakes, and the CC type of collisions will also not have trenches. Trench bhi nahi hoga. No subduction, no trenches. Okay? And these are continental locations. The continental locations of the fold mountains. They are away from the coast. And because बहुत compression hai, very strong forces hai, here the folds can get deformed. We will have complex fold systems. So if you asked me, so is it possible to have nappy structures and overturned folds in OC type? Yes, possible. जहां पर भी strong compression होगा, I'll have it. But strong compression is more likely in case of CC type. Okay, so CC type में पक्का होता है. Can we have them in OC type? Yes, we can have, but they will not be everywhere. Some localized areas. Okay, it's like अगर strong earthquake होगा, तो building पक्का गिरेगा. But can a building fall down when the earthquake is not strong? Yes, possible. But it will not be a common feature of a weak earthquake. Okay, I hope you got the point here. Okay, अगर heavy rainfall है, very heavy rainfall, तो floods पक्का है. But can I have floods when the rainfall is less? Yes, possible. Okay, but in that case, कुछ और reasons होगा floods का. So, can I have the complex features in the OC collisions? Yes, we can have. We can have faults also. We can have nappe structures. ये सब कुछ features Rockies में है. Okay, but as a prominent feature of the mountain system, they are more common in the CC type. So I hope you understand now what I mean by asymmetrical folds, what is a hogback feature, what is overturned folds, what is recumbent folds, and what are nappe structures. Revision done all of you? Okay, इसको आप ना लिख के याद कर लो. O टाइप में nappe होगा या नहीं? अभिरूप nappe तो मेरे घर में भी है. Okay, you know that is a different type of a nappe, but okay, we also had babies once upon a time. तो क्या हो सकता है? Logically possible. I do not know of examples. ठीक है? क्या dams with the earthquake of shallow earthquakes? शिवम आप बताओ, अगर आप पूछ रहे हो तो कुछ पढ़ा होगा, right? Can dams cause deep earthquakes? Okay, that's a less likely. कि डैम बना के आपने पानी को पहुंचा दिया कोर तक. Okay, वो इंडिया में हो सकता है. स्पिरिचुअलिटी में आप कुछ भी कर सकते हो. Okay, but can a dam cause shallow earthquakes या deep earthquakes? Shallow earthquakes. में डाउट क्यों है? शिवम चलो, okay, fine. There are two types of doubts, three types of doubts. One is a doubt that you are supposed to have. एक डाउट होता है to check the teacher कि औकात है कि नहीं, और एक डाउट होता है curiosity. Okay, अब बता रहे तो मुफ्त में ये भी बता दो, चलो ठीक है. ठीक है, so I do not know what doubt was that, but you classified yourself. I can be back now here. So I'm done with the collision boundaries and transverse boundaries. Okay, they are essentially plate slipping. Plate slipping, and I told you why it happens, because the convection cells can be misaligned. Okay, the convection cell on one side is moving like this, the other side is moving opposite direction. Okay, it's not a very common thing, but it can happen. One question, sir, transverse faults में volcanism हो सकता है कि नहीं? Yes, possible. अगर deep crack है हो सकता है, but it's not a common feature. Okay, so the common feature of transverse boundaries are faults. The common features of transverse boundaries are earthquakes. Can be a volcanism? Yes, but they are not very common features. And most books don't talk about examples beyond Juan de Fuca. So Juan de Fuca plate, North America, slips northwards. Okay, and you have the San Andreas fault. Utna kafi hai. I don't go beyond that. That's it. Okay, so three type of boundaries I've discussed. Then we moved on towards discussing what is the reason why the plates move. Why the plates move? The reasons are in the mantle dynamism. The mantle cells are moving, the magma is moving, the magma is powerful enough to drag the plates. So, fundamental reason is magma. Linked to this magma movement, we have got three type of forces. One force is the mantle drag, mantle pull or mantle traction. As the mantle moves, the plate also moves along with it. The friction that is pulling the plate along with it. We call that as mantle drag force or the mantle traction force. Second is, when the subduction is happening, the slab also has weight. Okay, so on its own weight, the slab can be pulled down. We call that as slab pull force. And third is, not a very powerful one, but it is still a significant one. At the more, as lava keeps coming out, the lava can keep on opening up the gap. Example diya tha, put a crossbar and try to pry open a crack. Okay, aap kuch gap mein, putting a knife and you're trying to open up the gap. Think of that type of a force. So, when lava comes out at the ridge systems, lava enters, solidifies, opens up the crack. We call this as the ridge push force. And of these, the driving one is the traction force of the mantle. That's the main force. A significant one is the slab pull force. Ridge force is not very powerful, but you can't ignore it. These are the three, and ultimately source of all the forces are the conditions of internal heat. Earth is hot inside, parts of the mantle is molten, some aspect of residual heat. The question not answered convincingly even now is, why do the mantle cells develop where they do? why some mantle cells are more powerful, why some mantle cells are not powerful and they die off eventually. ये जो mechanism है, I do not know. The geophysics doesn't tell us, I mean not convincingly at least, or books में नहीं आया अभी regularly, what are the reasons in the formation of the convection cells. So to say internal heat is right, but not a actual explanation to how the cells develop and how they ultimately mature or they die off. Then we moved on towards what are the evidences of the tectonics theory. So I grouped the evidences under 3-4 heads. One is all the evidences of the drift theory. The shape match, the structure match, the fossil evidence, and the paleoclimatic. All the 4 evidences prove that continents do move. Continents do break up. The concept of permanency of ocean is not right. The concept of permanency of continents is not right. This 4 Wegener had used. We agree with it. Then we have 7 evidences given by Moore concept of seafloor spreading. Whenever we have seafloor spreading, and ocean spreads, उसमें भी होता है. Evidences include the Moore, the axial rift valley, the volcanism, the transverse faults, the trenches, the accretionary prisms. The age of the ocean is increasing away from the Moore. These सारे points is also evidence of tectonics. But the 2 extra ones I discussed last class was how are earthquakes an evidence of tectonics. Earthquakes have a pattern in distribution. Earthquakes happen along the boundaries. Earthquakes happen along the inclined zone called as the Benioff zone. We have earthquakes at different depths, shallow focus, intermediate focus, deep focus. So 3 things. The pattern of earthquake distribution. Number 2, the intensity of earthquake distribution. And number 4, the source of earthquakes. ये तीनों चीज you can't understand and explain until you apply tectonics theory. The 3 things about earthquakes that confirm the plate motions. One is the pattern of how the earthquakes are distributed on the Earth's surface. The boundaries are the locations of the concentration of earthquakes. We talked about WWSSN, right? Worldwide Seismic Standard Seismic Network. This mapping helped us identify the boundary of the plates. Second is the intensity. कौन से earthquakes powerful होते हैं, क्यों होते हैं? Now we know better. The earthquakes along the trenches are more powerful. The earthquakes along Moore not as powerful. The earthquakes along CC type, a collision of continents is very, very powerful earthquakes. So the intensity of the earthquakes again explained by tectonics. And third is the source कहाँ से आ रहा है? Which earthquake is deep or shallow or intermediate? So earthquake evidences is one category of evidence, and the 4th one was the hotspot as evidences. So we said 3 things here. One is hotspots are from the deep mantle core boundary. और mantle से आता है. Remember, this is one thing is very clear. It is specifically mentioned that the core material does not come out. जो fluid core है, for whatever reason, it is not part of our volcanisms. Volcanism का source is always parts of mantle or lithosphere. So mantle से भी coming from deep core mantle boundary. The lava is very, very fluid, very, very basaltic. It comes out. That's one fact. Second fact is that these hotspots themselves don't move. This is confirmed. Look at that rock compositions. The source of the hotspot lava is consistent. And the third thing is that these hotspots are known to trace linear chains of islands. They are known to trace linear arrangement of islands. And these islands are not like archipelagos. Kuril Island एक linear chain है, Japan एक chain है, Indonesia एक chain है, but ये अलग है. These chains are archipelagos because of OC collisions. Because of OO collisions. The ones I'm talking about is the Emperor Seamount chain, the Midway Islands, the Hawaiian Islands, वैसे कुछ island chains हैं in the Indian Ocean. These chains are linked to the hotspots. The question is, how can a hotspot that is not moving, okay, trace series of islands? The only possibility is, okay, the plates must be moving. So I have one diagram for that. Yeah, this one. So the hotspot location is at the Hawaiian Islands here, right? ये consistent है, and the plate itself is moving north and westwards. So these are some of the islands of Hawaiian Islands, a group of islands. Okay, Kauai is 3.85 million years old. Oahu is again about 2-3 million years old. Molokai Islands, Maui Islands, and the active hotspot is the southern one. यहाँ पर भी 2-3 very famous volcanoes हैं. If you have heard about these volcanoes, we have volcano called as Mauna Loa. Mauna Loa, it is not as active. Then we have a volcano called as Mauna Kea. Mauna Kea is active. फिर एक है Kila Uyua, whatever, it doesn't go in my head. This is the most active one. So Hawaiian Islands also, the southern one, has a lot of these small islands. Okay? So you can explain this only if the Pacific Ocean is moving north and westwards. And that's how the Emperor Seamount Chain and the Midway Islands and the rest all have been formed. Okay? Acha, if you are curious about that, एक और diagram है, I didn't put it up, but ठीक है, if you want to know, I can share that with you. Kilauea. Okay. Can you see this here? So this is the southernmost island of Hawaiian Islands. Kilauea is here. ये eruption हुआ है last 2-3 साल में. Mauna Loa, this part of island is not as active. Okay, and Mauna Kea, ये एक active volcano. Okay, and these are the other islands. Maui Island, Molokai Island. Okay, we have this capital of Hawaiian is Honolulu here. Okay, and this is the biggest one, the big island of Hawaiian Islands. Abhay, छोड़ दो. All done, all of you? Okay. Please do look up the sheets we give you after the class. उसमें कुछ diagram extra add कर देते हैं हम, which I can't cover in the class. Some of that will have it there. All done, all of you? Okay. So I explained this now. Any questions from these topics? Anybody? Yes. Abduction is the accretionary prism getting pushed into the continents. एक टर्म आपके समुद्र सिंह में है, abduction. Abduction. This is the continent here. This is the accretionary prism. And we have subduction going on here. Sometimes the force is so powerful that these sediments can get forced into the continents. इसके अंदर चला जाएगा ऐसे. Okay. So this type of forced कुछ gaps होगा, कुछ rocks टूट गया maybe, the continents get deformed maybe. So this type of push is called as abduction. They are common in the OC type of boundaries. Yes. In prelims. ऐसा एक वेग सवाल कहां से उठा लिया आपने? Can we have? Yes, we can have. But in general, okay, it's not the major part. When collision happens, some parts can also slip. But North America, South America का Pacific boundary जो है, वो okay, it is actually a subduction one. But North America में, if I consider Juan de Fuca, that's a transform fault. Okay, so yes, you can say yes, but then it's not a main nature of that particular boundary. Yes, Shweta, the sheets I give you after the class, the part of post-class reference. उसमें model answers भी होते हैं, उसमें diagrams भी होते हैं. Spend maybe few minutes looking through what I add in your notes. Anybody else any doubts on this? This is the core. If you understand this, next 4 class आपका आराम से हो जाएगा. I'll only revise what I am teaching like in tectonics. Online, any doubts on this? Acha, okay, let's move on then. So I'm done with tectonics ka interactions. I'm done with what is the driving mechanism, and I'm done with what are the evidences. Short में give a subheading analysis of tectonics theory. Analysis of tectonics theory or evaluation of tectonics theory. Analysis and evaluation of tectonics theory. 2-3 points. One is, it is the most modern theory. It is the most modern theory. And convincingly explains most of the most modern theory, and it convincingly explains most of the landforms, earthquakes and volcanisms. Landforms, earthquakes and volcanisms associated with endogenic processes. Associated with endogenic processes. में जो भी process का origin, the source is the interiors of earth, this theory can explain fairly well. The comprehensive theory, that's why it is acceptable. One. Number two, okay. It explains how the crust of the earth was formed. It explains how the crust of the earth was formed and how continents and oceans get differentiated. How continents and oceans get differentiated. How is basalt formed? Now you know it's because of more. How is andesite formed? Now you know it's because of OC collisions, like ultimately CC collisions. Okay, so how the crust was formed, because देखो ये crust बहुत unique है. No other planet that we know of has the Earth's type of tectonics. Mars में है, but Mars also is not as active as the Earth. Like if any other planet has Earth type of tectonics, you can be sure पानी भी होगा वहां पर, and also be sure about life possibilities also. So the crust origin has been one of the big mysteries of geophysics. ये अलग-अलग कैसे हुआ? How does the ocean floor form, and how does the continent form? Okay, so this is an important part which tectonics explains fairly convincingly. Yes, you're right, Aditya. Some amount of tectonics has also been noted for Titan. Satellites we have of Mars, yes. So we do have some tectonics there also. Correct. Achha. The next point is tectonics explains continental drift. Tectonic explains continental drift and how the continents have changed in the past and how they may shape in the future. They have changed in the past and how they may shape in the future. So now we know that there was a supercontinent about 350 million years ago called as Pangaea. And now we know that आगे जाके another 250 million years I can have another supercontinent. In fact, some books mention the possibility of Pangaea Ultima. Okay, ये एक और आगे जाकर एक और बन जाएगा. But again, Africa and Eurasia would have merged together. Okay, Africa would have come and collided with North America. Okay, so how continents have changed shapes and they can change in the future, the theory tells us. So these are the positives of the theory. Okay, and add एक और point add कर लो that it explains that the theory explains how the surface features are related to mantle dynamics. The surface features are related to mantle dynamics. Okay, there's a relationship between what's happening in the mantle and what the consequences are on the surface of the earth. Okay, ये positives हैं. Now, what are the limitations? I will not say negatives, I will say limitations. Because देखो इस theory में ऐसा कोई glaring mistake नहीं है. Okay, but the theory is still not complete. There are still a lot of questions which have not been answered convincingly. Okay, so ultimately my search is I want to know a comprehensive theory. कि एक theory बता दो जो सब कुछ बता देगा हमें. तो वैसा नहीं है theory. Head on. Although there are no errors as such, but there are certain aspects which are not well explained. There are certain aspects that are not well explained. Number one, the genesis of mantle convection cells. Some aspects not well explained. One is the genesis of mantle convection cells. Number two, the genesis of hotspots. The genesis of mantle convection cells, the genesis of the hotspots. Number three, अब देखो ये जो टेक्टोनिक्स थ्योरी है ना, हाउ इट इवॉल्व, द प्लेट टेक्टोनिक्स थ्योरी, okay, there is one that explains all events from the Pangaea that existed 350 million years ago. Okay, so ये जो Pangaea था, यहां से कहानी शुरू हो रहा है. Okay, and this time is called as the Carboniferous times. Okay, so the tectonics theory ka this was the main beginnings of tectonics theory. Then we have another version that tells us the events before the Carboniferous times. So Pangaea के पहले क्या था? That was not explained initially. And this is a bit different. This we call as microplate tectonics theory. So when I am discussing the merits of tectonics theory, हम इसकी बात कर रहे हैं. But then this theory was not convincing to explain the first beginnings कैसे हुआ था. The first crust कैसा था? Okay, what was the first continent like? What was the first ocean like? What the first mountains which were formed? This is a sub-theory now. And together we call this as the modern plate tectonics theory. when I'm evaluating, this one हम इसके बता रहे हैं that the original form में the tectonics theory did not explain what happened before the Carboniferous times. Back to your notes. Write down. The tectonics process before the Carboniferous times. The tectonics process before the Carboniferous times was an additional theory under microplate tectonics. Under microplate tectonics. It explains the origin of the Earth's crust. It explains the origin of the Earth's crust, the formation and the nature of the first continents. The origin and the formation of the first continents and their evolution into the Pangea supercontinent. And the evolution into Pangea supercontinent. ठीक है, तो इसमें थोड़ा डिफरेंस है. The continents which are formed here, okay, are not exactly same as continents which are now being discussed here. तो ये अलग थ्योरी है, but now it's reconciled more or less. ये दोनों को मिला के we say this is the modern plate tectonics theory. Okay, and the last point देखो, now see, एक mystery है. If you look at the divergent boundaries and the convergent boundaries. The divergent boundaries are where the ocean floor is forming, and the convergent boundaries are where the ocean crust is getting destroyed. And convergence of CC में even continents are getting destroyed because उसमें collision होता है, crush होता है. Okay, they are parts of what we call as continental fusion. If you compare the rates, you'll find the divergent boundary activity is more powerful. We add up all the boundaries of the Earth, how much amount of crust being destroyed and how much amount of crust is forming. You'll find इनका balance है नहीं. The divergent boundaries are more powerful than the convergent boundaries, which means the Earth is adding crust. इसका क्या ये मतलब होगा कि Earth is becoming larger in that case. Now for that we do not know. As long as we study tectonics, हमने assume कर रखा है कि Earth has a conserved surface area. But looking at the activities, it looks like maybe Earth is expanding. Because एक old theory था called as Ham's expanding Earth theory. Ham's expanding Earth theory, which has not been accepted, but now they say कि इसको दोबारा देखना पड़ेगा. It's possible that we missed out something which Ham was able to talk about. Okay, so write one last point right down here. That most of the concepts of tectonics theory, is based on the assumption of constancy of Earth's surface area. Is based on the assumption of constancy of Earth's surface area. That is, Earth's surface area is conserved. Constancy of Earth's surface area, or the surface area of Earth is conserved. However, okay, divergent boundaries are more active boundaries than all convergent boundaries taken together. The divergent boundaries are more active boundaries compared to all convergent boundaries taken together. This necessitates a re-examination of expanding earth hypothesis. It necessitates the examination of examining the expanding earth hypothesis of HALM, H-A-L-M, HALM's expanding earth hypothesis. So Raji, I said no कि टेक्टोनिक्स में कुछ गलत ऐसा कुछ नहीं है, glaring mistake नहीं है, but lot of unanswered questions. So you know we have mysteries on both extremes. The mysteries about the universe and astrophysics beyond Earth, and equally big mysteries inside the Earth. Both are not completely known to us. We probably know a very small part. We just scratched the initial understanding of what the Earth is. Okay, but it's an evolving theory. Hope to refine it as we understand things better. All done, all of you? Okay. Now, to give an idea to you कि questions कैसे पूछे जाते हैं. Last couple of years में tectonics पे questions है ही नहीं. Okay. The bulk of the questions asked tectonics were asked earlier. So write down some questions. Okay. A very old concept question was 1988. लिखो question लिखो please. 1988 में critically analyze tectonics theory. Critically analyze tectonics theory and bring out the evidences in support. And bring out the evidences in support. ठीक है, ये 88 में पूछा था. Then we had one question in 1990. Write a short note on tectonics in 200 words. A short note in tectonics in 200 words. ये सबसे frustrating हुआ होगा. Okay, इसमें क्या लिखे? 200 वर्ड में लिखना है आपको. And class itself is 3-4 classes across 40-50 pages. Okay, so I don't know what they must have done. Okay, this was one question. Then one question was in 1995. Limitations of drift theory and how tectonics improved it. The limitations of tectonics theory and how tectonics theory improved it. एक 1998 में है. Okay, volcanicity and tectonics. A proper question है, but I'm giving you the keywords. The concept of volcanicity and how does tectonics explain it? So volcanoes and tectonics को जोड़ के पूछा. This was in 1998. जो क्वेश्चन पूछा था 96 में, the same was repeated in 99. Again, distinctions between the drift theory and tectonics theory. In 1999, distinctions between tectonics theory and the drift theory. 2000 में fold mountains and tectonics theory. Fold mountains and tectonics theory. 2005, no, 6 में evaluate continental drift hypothesis. Evaluate continental drift hypothesis. 2008, a note on seafloor spreading. Note on seafloor spreading. 2014, tectonics and माउंटेन बिल्डिंग, हिमालयाज एंड एपेलेशियन पूछा था। 14 में टेक्टोनिक्स एंड माउंटेन बिल्डिंग। In mountain they asked, how does it explain formation of Himalayas and Appalachian mountains? Specifically पूछा। On an Appalachian mountain formation, I have a short video on YouTube again. So technical है, so go back and have a look. Just type my name, Edukemy, and Appalachian mountains. You'll have 10 minutes का video. Okay, so it is part OC collision, it is part CC collision. It's a complex landform, Appalachians. Okay, look that up. Then 2019, they've asked compare, contrast the different types of plate boundaries. Compare, contrast the different types of plate boundaries. In the notes that we are sharing, उसमें एक table आपको बना के दे देंगे हम. Okay, have a look at that table. Then the last question they asked was in 2021. 21 they asked, how is tectonics derived from? Derived from isostasy and continental drift. How is tectonics derived from isostasy? ISOSTASY. मैंने पढ़ाया नहीं आपको अभी. From isostasy and continental drift. Okay. This was in 21. एक और indirect है, लिख लो इसको. 25. This year they asked the geological processes leading to formation of nappies in mountain belts. Geological and tectonic process leading to formation of nappies, NAPPES, nappies in mountain belts. 10 mark का question था. Can you see how the questions are evolving? As you are, looking at older questions, complex नहीं है, straight questions हैं. Tectonics क्या बता दो, limitation क्या बता दो. Okay. As you're moving more recent questions में, they are making it very, very specific. बताओ पूरे पढ़ाई क्या, we had one statement on nappies, और nappy पे पूरा proper question पूछा गया है. And extra पढ़ना नहीं है. इसी को समझाना है in a 10 mark question. How are nappies formed? So nappies are features of complex fold systems. Explain करो क्या होता है. Draw short diagram and show it. The nappies are formed more commonly in CC type of collision and not O type and not common in OC type. फिर समझाओ उसको. Then tell us nappies are in Himalayas. In what part Himalayas? ठीक है? So same content you must elaborate and write in 10 marks. एक और था, I mean, tectonics word use नहीं किया, but it's understood. 24 में लिखो, examine the recent views of mountain building process. Examine the recent views of mountain building process. And divide the mountains on the basis of their genesis. Divide the mountains on the basis of their genesis. Fold mountains, volcanic mountains, block mountains, escarpments, ये अलग-अलग type के mountains होते हैं. Okay, this was asked in 24. The recent view of mountain building means tectonics theory. Okay, how are mountains formed? Okay, explain and then tell us the different type of mountains. Okay, so recent years में not too many questions, but whatever they're asking now a bit more specific details on the theory and not generic. एक लिख दो एक note on tectonics theory. All fine? Okay, चलो we move on now. Now the next 3-4 topics are linked to tectonics. मैंने पढ़ा दिया है, I will organize for you. The next topic is volcanism and volcanicity. It means the same things. Volcanism and volcanicity. It means the same thing. So, what's volcanism? Volcanism is a process in the creation of magma. It includes the movement of magma through the interiors and includes landform formations. Okay, because of such magma activity. When you say volcanism, it is three things. One is the magma creation, bana kaise? Second is how does the magma move through the interiors? Mantle se kaise move karta hai? How does it move through the lithosphere? And finally, how this magma movement creates the landforms. The landforms can be extrusive landforms, landforms can be intrusive landforms, and what are the types there? Okay. This is magma, volcanism, and volcanism is the most fundamental concept in tectonics process. It is the most fundamental concept in tectonics process. Because all the plate dynamisms and the events associated, all the plate dynamisms and the events associated have their origins in the magma creation and its movement. Have their origins in the magma's creation and the magma's movement. Okay. Next point. The source of magma is mantle largely and linked to the internal heat. The source of magma is the mantle largely. Why I say largely? Because kuch magma lithosphere se bhi aa sakta hai. Some part lithosphere can also melt. But the main source of magma is mantle largely, and it is linked to the internal heat. As internal heat, now you know this. This is the residual gravity heat as Earth cooled and accreted from the nebula, plus it's also because of radioactivity. It has two sources. One is residual gravity heat. When Earth was forming, the residual, jo bach gaya, residual gravity heat as Earth cooled and accreted, it became solid. As Earth cooled and accreted from the ancient nebula, and the heat source is also a radioactivity. ठीक है? अच्छा, now, before I write anything else, सुन लो आप. Now see, rocks, minerals, we have got elements, and we have magma. ये चारों चीज सेम नहीं है. Okay, elements like iron, elements like nickel, elements like magnesium, elements like silicon, oxygen, elements. They combine together, we have minerals. Minerals are compounds. Okay, silicate minerals, sulfate minerals, sulfide minerals, okay, carbonate minerals. ये compounds हैं, and the compounds will have fixed properties. उसका एकदम structure same है, the chemical property, the physical property, all are same. Rocks are mixtures of minerals. Rocks are mechanical aggregates. ये compounds नहीं है. Rocks are not compounds. Okay. So when I say granite or limestone or basalt, sandstone, marble, ये rocks हैं. Rocks are not minerals. Rocks are a mixture of minerals. So when you melt a rock, the entire rock does not melt at the same time. Okay. Rock is made up of different components. जब rock melt करोगे, अलग-अलग temperature में अलग-अलग part melt करेगा. So, for example, I have a substance. It includes A, B, and C. Say A has a melting point of 1000 centigrade, B has a melting point of 2000 centigrade, and C has a melting point of 800 centigrade. Okay, and I put it in a container and I'm heating it. When I'm heating it, okay, and the molten material is now flowing out. So imagine ये rock है. आप जब हीट करोगे, सबसे पहले क्या मेल्ट होगा? C will melt first. So what comes out is C first. उसके बाद में क्या मेल्ट करेगा? A melts. Then probably A will come out. Then and last में क्या मेल्ट होगा? B. So when you melt the rock, you say this rock का नाम है X. You don't get molten X directly. You first get what? Okay, one which has the least melting point. This is one type of fractional melting बोल लो. Now you have this process of fractional distillation. You have a liquid mixture and you heat it, petroleum. At different temperature, different parts of that gas or liquid will evaporate. And that's how they separate the different type of liquids. So our point here is, when you melt X, you don't get X. You get C. You can get A. Okay, so imagine, okay, this is the Earth's surface here. And this is a massive rock melting. When it's melting, the lowest melting point will first rise up and come out here. So you are melting a rock called as X. आपको मिल रहा है rock called as A. So matter all of you here? Plus, while moving, okay, you can also transform. बहुत pressure है यहाँ पर. There is enormous amount of heat. The X is made up of A, B, and C. The A melts. A while going up again transforms. ये शायद A भी नहीं आएगा. ये कुछ यहाँ पर Y आएगा वहाँ. So if mantle is made up of peridotite and I melt it, I will not get peridotite here. A part of it will melt, start moving upwards, gets transformed, निकल के आएगा basalt. You are melting basalt. Okay. You will not get basalt here. इसका एक part melt होगा, ऊपर जाते जाते convert हो जाएगा, बाहर निकलते निकलते it will be andesite. This was a fundamental doubt many of us had. Why do we have andesite at the archipelagos and why are hotspots basalt? ये क्वेश्चन पूछ रहे थे आप लोग, some of you. So this is a process of melting. इसका बहुत geophysical aspects हैं. There was one scientist called as Bowen, a Canadian geophysicist. He gave us what's called as partial melting series, and it's almost iske bahut versions, remember, there are many series of this kind. Okay, but the more popular one, the simplest one that we are supposed to know is that when you melt peridotite, partial melting, you will get basalt. When you partial melt basalt, you will get andesite. And when you partial melt andesite, you will now get granite. आपको ये सीरीज याद रखना है. So which rock is melting where, that decides what type of lava comes out. Okay, so give us some heading in your notes. लिखो, समझा देते हैं आपको. Okay, partial melting process of magma. Partial melting process of magma. Write down. Unlike minerals, which are compounds, with fixed properties and composition, rocks are mechanical mixtures of minerals. Rocks are mechanical mixtures of minerals. Rocks do not have fixed properties. They do not have fixed properties. Next, write down. When rocks melt, the magma formed depends on the sequence of melting of rock minerals. When rocks melt, the magma formed depends on the sequence of melting of the rock's minerals and their transformation under high pressure and temperatures. Is it okay, all of you here? When the rocks melt, okay, I will not get the molten rock directly. The magma I will get depends on क्या sequence से melt हो रहा है, what is melting first, okay, and how while moving it gets converted, what melts next, and while moving how that gets converted. And I'm sure this is far more technical, but हमारे औकात के लिए इतना काफी है. Okay, beyond this we again become geophysicists. Okay, so our fundamental point is that rocks while melting they get transformed. This is our idea. Write down. This process is called as partial melting. I hope you understand the word partial melting. When you are melting this one, a part of it melts first, right? इसलिए बोलते हैं partial melting. So first C comes out, partial melting of C. Then A comes out, partial melting of A, and so on. Okay. So this process is called as partial melting, and there are many series. In the sequence of the types of magma creation. There are many series in the sequence of the type of magma creation. जैसे ये एक सीरीज है, ये रॉक सीरीज, जैसे मिनरल का भी सीरीज है. Olivine will partial melt into amphiboles, will partial melt into mica, उसका भी अलग सीरीज है. Okay, so there are many such series. Write down. The most common The most common is the Bowen partial melting series, POWEN. The most common is the Bowen. Most common, more simple is Bowen, BOWEN. Bowen's partial melting series. और ये लिख दो आप please. Petrotite, partial melt gives basalt, partial melt gives andesite, partial melt gives granite. Andesite, partial melt gives us granite, partial melt gives us basalt, and this is the main rock of the mantle. This is rich in olivine mineral. Granite is rich in non-ferromagnesium silicates, quartz, feldspar rich होगा ये. Okay. Basalt is rich in ferromagnesium silicates. Andesite is a transition one. Okay. So petrotite converts into basalt, converts into andesite, and that converts into granite. All done, all of you? Achha. Now, I want you to know one property here. Okay, this is for your a bit more understanding. These rocks, these are the densest rocks. These are the lightest rocks. इस series में. These rocks, they have a high basicity, pH value. I come here, this will be acidic rocks. These rocks are soft or softer. These rocks are harder. And when you melt these rocks are more fluid, and these rocks are more viscous. They are more thicker. Which type of eruptions will cause powerful explosions? The more fluid ones or the thicker ones? The thicker ones. So जहां पे eruptions andesite or granite होगा, they are more powerful eruptions. जहां पे eruptions basalt होगा, they are more quieter ones. Okay. So remember this, that basalt, these are quieter or volcanic eruptions, whereas andesite and granite जो हैं, these are more powerful or volcanic eruptions. They are more destructive. This is more quieter and this is more destructive. बस आपको इतना याद रखना है. And I don't think they'll ask this question to you, but you can use it to explain what type of earthquake, what type of volcanisms are more destructive. ठीक है? Okay. They are denser because these rocks are more mafic rocks, and these rocks will be more felsic rocks. दोबारा टेबल देखो. You have any doubt, ask me. Petrotite, basalt, andesite, granite. ठीक है? The densest rocks, they're heavy. Okay, they make up the interiors. And these are the more lighter ones. इधर बाहर आ जाएगा. Okay, these are more thicker when molten. ये हल्का है. When you melt it, it is more thick. Example best है water and oil. Okay, which is more thick? Oil. Which is lighter? Oil. ठीक है? So water is fluid, okay, but heavier than oil. याद रहेगा भी all of you here? So these are lighter but more thicker. These are denser. When they melt, they become more fluid. So इसी से okay 2 points. Okay, or point number 1 is for memorization. Basalt eruptions are quieter. They are quieter. They are less destructive eruptions. Andesite and granite eruptions, these are more powerful because the lava is viscous. यहाँ पर the lava is fluid. Okay, basalt eruptions are quieter, less destructive eruptions. जहाँ पे basalt lava eruption होता है ना, there you can have volcanic tourism also. आपको घुमा के लेके जाके दिखा देंगे, देखो लावा निकल रहा है. Okay, you can jump over the lava stream maybe. Okay, सामने लावा निकल रहा है, बैठ के यहाँ पर चाय पी रहे हो, ठंडा हो गया जाके चाय गर्म करके आ जाना. Hawaiian Islands has this. They have volcanic tourism. यहाँ पर you get nirvana. You go for tourism here, फिर तो आप spiritual level पे चले जाओगे. You won't come back to tell us what happened. Okay, so these are more powerful ones. These are more destructive ones. यहाँ पर होंगे tsunamis, you'll have powerful eruptions, damage and all of that. ठीक है? अच्छा, एक और fact याद रखो. Basalt and andesite, these are extrusive rocks. ये बाहर आ जाएंगे. Okay. ये कुछ properties हैं, remember it. Basalt and andesite are extrusive rocks. They come out. Granite is intrusive rocks. They'll stay inside the earth. They won't come out. Granite is the thickest one, most thick, most viscous. वो बाहर आते आते ठंडा हो जाएगा. Okay, so granite is intrusive rock. Basalt, andesite, they are both extrusive rocks. याद रहेगा आपको all of you? Remember we talked about OC collision में granite lava जो है वो बाहर आता है क्या? It remains inside and becomes the core of the mountains. They become the batholith इसीलिए. But these two can come out. Lava can form lava plateaus. Lava can form islands. Andesite can form volcanic peaks on the mountains. Granite will never come out. Granite is always intrusive. So granite के साथ में एक और common rock है called diorite. Both these rocks. These rocks will form intrusive landforms. Like we mentioned batholiths. Landforms and core of the mountains, core of the continents. Is it okay, all of you? Yeah, of course, yes. So all these are examples of igneous rocks formed from melting and cooling of lava or magma. एक बार revise कर and ask me if you have doubts here. This is the main concept of volcanism. Okay. And this is not there in NCERTs, not there in your Savinder Singh either. So इसको आपको पूरा लिखना होगा from the class notes. What is partial melting? Bowen series and the properties of the four rocks. Broad, dense say lighter, soft say harder, basic say acidic, fluid lava say you have got viscous lava. Yes, if you go deep mining, मिलेगा ग्रेनाइट आपको, अंदर रहेगा, अंदर could be, okay, you can reach it through mines. मैंने कैसे सीखा? बेटा मैं फेल मारते मारते सीखा. तो अगर मेरे तरह सीखना है तो अलग बात है, ठीक है, ज्वाइन द क्लब. Okay, I need lot of help in teaching. अगर मेरे तरह सीखना है, जो आपको बता रहा हूं मैंने 20 साल में सीखा है, आपको सिखा रहा हूं 6 महीने में, होपफुली. Now see, there's a difference between you studying geography to become geographer and geography because आपका interest है, और एक geography marks ला के qualify करके निकलो यहां से. It's your choice. Lot of aspirants enjoy the process of preparation. इतना enjoy करते हैं कि हर साल दे ही रहे एग्जामिनेशन. वो एडिक्शन हो जाता है, मजा आता है बोलने में. मैं आईएएस की प्रिपरेशन कर रहा हूं, अपना दावरी का दाम बढ़ा रहे हैं ना. एक एडमिट कार्ड, सेकंड एडमिट कार्ड, थर्ड एडमिट कार्ड, फोर्थ फिफ्थ, ऐसे कंपाइलेशन. अब कुछ घटिया लोग एक एडमिट कार्ड के बाद में क्वालिफाई कर जाते हैं. हाउ बोरिंग इज दैट? यू डिसाइड व्हाट यू वांट टू डू. ठीक है? एनी डाउट्स इन दिस एनीबॉडी? हाँ बताओ. क्वालिटी? Yeah, what type of silicates? Are they ferromagnetic silicates or are they non-ferromagnetic silicates? जो भी प्रॉपर्टी ऑफ मिनरल के लिए है. The type of quartz है, अगर फेल्सपार है, अगर ऑर्थोक्लेज है, they will become thick lava. अगर ओलिवाइन है, रिमेंबर एस्ट्रोनॉस्फेयर याद आ रहा है ओलिवाइन वाला, वह सॉफ्ट होता है ना. You apply pressure, it will flow. So olivine rich rocks will be very soft. So I gave a sequence, अगर आपको याद है, quartz, feldspar, orthoclase, muscovite, biotite, amphibole, pyroxene, olivine. Okay, so olivine is the densest one, but it is the softest one. Quartz, lightest one, but the hardest. Diamond के बाद next hard substance is quartz. Okay, so the property of the rocks depends on the composition of or the proportion of silicate minerals in that rock. ठीक है? Explain melting point again. क्या मिस किया मेरे बच्चे? जल्दी मेल्ट हो गया, धीरे मेल्ट हुआ. मेल्ट होते होते हार्ड रह गया, सॉफ्ट रह गया, और कुछ नहीं बताया मैंने. Yes, granite is not extrusive. Granite is intrusive rock always. और जहां पर ग्रेनाइट दिखाई दे रहा है, it is because the intrusive rock has got exposed. This is the earth surface. This is a granitic rock or landform. ये softer sediments हैं. Over time, this can get eroded. And now the granite has been exposed. तो अगर आपके गांव में ग्रेनाइटिक माउंटेन है तो आपका गांव बहुत पुराना है, सेडिमेंट सभी रोड हो चुका है. That's how the granite is now exposed. That's possible. Granite can be exposed. But while formation happens, granite has to be inside. Okay? I'll move on now. ठीक है, इसके बाद अब लग रहा है वो curiosity वाला क्वेश्चन बन रहा है. So now, what type of magma is at what locations? Okay? So give us subheading now. Distribution of volcanoes and the associated features. I've explained the mechanism of volcanism. Now give us a heading: distribution of volcanoes and the associated features. And the associated features. Volcanoes, and it's all tectonics, okay? I'm revising it for you, so I will not dictate. I'm writing, you keep pace with me. Which means basalt eruptions, magma will travel farther. Yes, something of that kind. Travel farther, as in come out of the surface. Correct. Granites बहुत जगह हैं. Granite, okay, wherever exposed होगा, granite is a very common rock found across India on the peninsular plateau. And more common is diorite. That is more like granite, but it's more common. Okay, so one type of volcanoes are the Moor volcanoes. Moor volcanoes में क्या melt कर रहा है? Which part of earth is melting at Moor? At Moor, what is melting? The mantle rocks are melting. Mantle is what type of rock? Peridotite. What will come out? Basalt. Okay? So Moors are what? This is, okay, a source of magma is mantle peridotite. Therefore, we will have basaltic eruptions. And this is therefore formation of ocean basalt floor. ओशन का फ्लोर बसाल्ट क्यों है? बिकॉज ओशन फ्लोर बन रहा है एट द मॉर लोकेशन, और मॉर पे बसाल्ट ही आ सकता है. देन द मॉर वोल्केनिज्म, okay, this is the source of the magma is mantle peridotite. So what it gives you is, it gives you basalt eruptions. Basalt eruptions, and this leads to formation of the ocean basalt floor. ठीक है? How is the ocean floor formed? And these are quieter eruptions. They are not associated with tsunamis. Atlantic Ocean, मोर पे बहुत eruptions हैं, but you not hear about tsunamis in along the coast of Atlantic Ocean. हो गया आपका डन? मोर वाला हो गया. The next one, number 2. OO collision volcanoes. यहां पर source of lava क्या है? The source of magma is what? The subducting ocean lithosphere, which is basalt. The source of lava, magma, is the subducting ocean basalt. तो basalt partial melt क्या बनने वाला है? Therefore andesitic, volcanic arc, andesitic, archipelago. हो गया? Basalt partial melts gives us andesite. और एंडेसाइट है तो थिक है, राइट? So this will be explosive, destructive, so if you understand tectonics, ये 2-3 टॉपिक आराम से निकल जाएगा आपका. The only repeat of the ideas in a organized, okay, format. OC हो गया आपका? Now come to the third one. थर्ड क्या है? OC हो गया. OC collision. OC collision में source of magma क्या है? Again the source is subducting ocean basalt. And what they will create will be andesite volcanic peaks. अब आइलैंड्स नहीं बनेंगे. यहां पर आइलैंड्स बन रहे थे, यहां पर वोल्केनिक पीक बन रहा है. Chimborazo, Cotopaxi, okay, Mount Denali, Mount Ojos del Salados, andesitic volcanic peaks, and these also are explosive. St. Helens Mountains. Is it okay? Now I'll add one point concept here. Watch here. At the junctions of OC collisions, okay, ये जो sediments हैं, sediments includes scraped ocean sediments. The sediments includes crushed andesitic rocks of archipelagos. Sediments also includes some of the crushed continent rocks also. Remember all of you here? These sediments are far more complex than the sediments of the OO collisions. O collisions में क्या है? Ocean sediments are getting plastered. Ocean floor is getting plastered. But यहां पर composition देखो. Here you have got ocean sediments plus the archipelagos which are formed of the O type. वो भी crush हो जा रहा होगा. वो add up हो रहा है. Continents are getting crushed. So in this sediments, you also have certain andesitic minerals also. You also have some andesitic minerals. So when the subduction happens, the bulk of subduction is basalt. And when basalt melts, right, I will get andesite. Andesite is extrusive. बाहर आ गया. But in this process, can you all imagine that some amount of andesite भी with the floor अंदर खिंच जाएगा ना? Is it possible? Is rubbing going on, right? Not much, but थोड़ा बहुत तो जाएगा अंदर. Some amount of continent andesite also is pushed inside. And when these melt, what do I get? I get granite. So at the OC collisions, I have source for andesite eruptions, जो basalt से आ रहा है. I also have granite eruptions, जो आ रहा है from the andesite rocks which are getting pushed into the mantle. And this granite is thick. Okay, this granite is very viscous. ये बाहर नहीं आएगा. ये क्या होगा? It becomes the batholith of the continents. So under this massive mountain, ये जो massive fold mountain यहां पर है, it's a huge fold mountain here. Under this massive of sediments of the fold mountains, okay, इसके नीचे there is a batholith core. There is one large core which is of granite rocks which is not coming out. तो ये एडिशनल फीचर है at locations of the OC collisions, not at the OO collisions. All done, all of you? So back to your notes now. Okay. हम बता रहे थे कि OC में क्या होता है. OC में, so one is the source is the subducting ocean basalt. We also have a second one. Okay. We also have a source is, okay, source is andesitic rocks of the continents and island arcs. बहुत ज्यादा नहीं है, but enough to melt and give us rocks. The one is source is the subducting oceans basalt, and we also have source in the andesitic rocks of the continents and island arcs. And what this gives, partial melting will give us granite magma that is thick and remains as intrusive landforms. Thick granite that remains as intrusive landforms. बताओ इसमें क्या समझ में नहीं आया? You know this table, you are home. Okay, and I hope you realize that ये दो जो है, these are features of trench boundaries. They are features of circumpacific belt. These are the most destructive volcanism locations. Okay. OO type and OC type, they are along the trenches. This is not the trench one, this is the more one. They are along the trenches. They are the features of circumpacific belt. जो OO type है, this is North and Western Pacific. And the OC type is Eastern Pacific. Yes, yes, Hemant. All done? The features of trench boundaries, the features of Pacific Ocean, and these are therefore the most destructive areas of volcanic eruptions. In fact, यहीं पे ऐड कर लो, circumpacific belt. The circumpacific belt accounts for more than 80% of the world's destructive earthquakes and more than 70% of the powerful volcanic eruptions. The circumpacific belt accounts for more than 80% of the world's powerful earthquakes, destructive earthquakes, and 70% of the world's powerful volcanic eruptions. ठीक है, लिख ही रहे हैं तो यहां लिख लो some examples of powerful eruptions. Examples of powerful volcanic eruptions of the circumpacific belt. Of the circumpacific belt. ठीक है, the more famous ones or infamous ones. एक है फिलीपींस में पिनाटोबू, Philippines. Philippines also has Tal, T-A-A-L, Tal. Both are very powerful ones in Philippines. And ये अभी continue erupt कर रहा है. Pinatubo is in news always. Philippines में. In Indonesia, we have Merapi, Tambaro, और एक है I think Mount Lucky. The full name I'm forgetting. एक लाकी इसी साल इरप्ट हुआ है इन आइलैंड कॉल्ड फ्लोरेस आइलैंड्स ऑफ इंडोनेशिया। तो हम दिखा देंगे आपको। दिस इज इंडोनेशिया में ही है, इन आइलैंड कॉल्ड एज फ्लोरेस, FLORES, फ्लोरेस। ऑल द थ्री आर इंडोनेशियन इरप्शंस। मिरापी इज वेरी पावरफुल वन, सो इज एंड इसी बेल्ट का पुराना वाला था, द मोस्ट पावरफुल वन रिकॉर्ड इन ह्यूमन हिस्ट्री इज काराकटाओ। ठीक है, इस पार्ट ऑफ द बेल्ट, इंडोनेशियन बेल्ट का पार्ट है, इंडोनेशिया वाले ये है। देन एक बिग वन नेम टोंगा आइलैंड्स में टोंगा हाई पाई। दिस इज इन रिसेंट टाइम्स काफी पावरफुल रहा है इन टोंगा आइलैंड्स। टोंगा हाई पाई इरप्शन इन टोंगा आइलैंड्स। This is in news. Then in North America, we have eruptions of St. Helens. St. Helens is in US. Cascade Ranges, Rainier Mountains. St. Helens. Mexico में eruption है Popocatépetl. This is in Mexico. Yes, Levotobi, lucky, yes. Thank you. It is Levotobi, LOWO, Levotobi, lucky. They keep asking this question. GS में पूछा हुआ क्वेश्चन था एक. Explain the recent eruptions. You have to know the names. You just cannot say कि हाँ eruption हो रहा है. नाम बता के बताओ कहां पर हुआ है in recent times. Yeah, Flores Islands, Levotobi, Laki in Flores Islands, eastern part of Indonesia है. And Merapi and एक Tambaro among the big ones. Okay, and then all the others are active. Cotopaxi, Chimborazo, you know the names now. Okay, so these are the ones which are more in news. अच्छा, एक और आप जान लो, I forget that name of that. I have it in my diagram. In Kamchatka Peninsula, I'll show that to you. The name is, yes, Krasnennikov volcano. ये लिख लो आप लोग. This is in Kamchatka. इसी साल इरप्ट हुआ है, जुलाई जून में. Krasnennikov volcano in Kamchatka Peninsula. And earthquake यहाँ पर was very powerful one. It was almost 8.5 in the Richter scale. Top 10 earthquakes में से आ जाता है ये वाला. And the fear of tsunamis was as far as, fear क्या हुआ tsunami, but not as powerful as far as Hawaiian Islands. देखा आपने ये वाला? Krasnikov volcano, July 29, earthquake was 8.8. 8.8 in Richter scale is considered as top 10 earthquakes of the world. I think 5th or 6th position mein hai in terms of their intensity. In fact, I had drawn that also to show you the impact. Yeah, this one. Okay. Here देखो the impact of the volcano. Okay. This earthquake, it impacts tsunamis as far as Hawaiian Islands. A region called as Kurils, वहां से आ गए और एक जापान को भी हिट किया. So ये न्यूज में, and these are the ones they ask you in your prelims. The unfortunate part बोलो या whatever you call it, in the GS prelims classes geography में, I think 95% of time is spent in discussing theories. But उससे question zero हैं. If you look at the prelims questions, there are no direct questions on tectonics. Zero. But linked to tectonics, volcanoes हैं, earthquakes हैं, and classes में वो पढ़ाया नहीं जाता है. Lack of time essentially. And in optional, these names are not as important. The more important part is the theory part. But with the names, you consolidate your GS part also. So know these names, please, all of you. Well, we'll see how I can help you for prelims. वो बाद में. इतने पैसे थोड़ी दिए आपने कि मैं prelims से पढ़ाऊं. सब मुझसे करा रहे हो, डिस्काउंट मांग लेते हो. All done, all of you? Examples of the volatile or disturbed earthquakes of the world. Back to your notes. So I'm done with I'm done with the 3 type of eruptions. Yeah. Now the 4th one. We have done OOC. The 4th is hotspot volcanisms. The 4th, the hot spot volcanisms. The hotspot volcanisms, the source of magma क्या है? The very deep mantle. This is very, very mafic, ultra mafic basalt. Sorry, ultra mafic peridotite. So what this will give us is very fluid basalt. It will give us very fluid basalts. And hotspot volcanisms, now you know, these are not along the boundaries. These are intraplate. These are mantle plumes. What are hotspot eruptions? They are not along the boundaries. They are away from the plate boundaries. They are intraplate. Intraplate, and they are because of mantle plumes. Mantle plumes coming from the deep mantle, from near the core mantle boundaries. इसीलिए इसके eruptions are very fluid basalts. But basalt extrusive है कि intrusive है? Extrusive है, बाहर पक्का आएगा. But it'll come out very quietly. अच्छा, now listen. Say I have 2 surfaces, okay? I have a surface which is soft. Imagine a plastic surface, soft plastic. और एक surface है, a hard one, like glass. Glass is hard? and plastic is softer. I take a very sharp knife and I puncture the plastic and I puncture the glass. In which case, will the puncture be a neat hole? And in which case will it be a cracks? Yeah? I have a soft plastic and I have a hard brittle glass. Cracks इसमें होगा. Glass में cracks होगा. Okay. Soft में क्या होगा? एक hole बन जाएगा आपका. I have oceans which are soft basalt and I have continents which are hard, okay, rocks of continents. So when I have hotspots can be anywhere under the continents, under the oceans also. So the hotspot punctures the ocean floor. ये cracks बनेगा कि hole बन जाएगा? ये hole बन जाएगा. Okay. And when I have puncture in the continents, कैसा बनेगा ये वाला? ये cracks बनेगा. Imagine here, I have ocean floor and I have a thick continent. Both of them have hotspots. यहाँ भी hotspots हो रहा है, यहाँ भी hotspots हो रहा है. In the oceans, the hotspot will create what? A hole. We call this as central vent. A continents में पंचर करेगा, ये क्या बनेगा ये वाला? There will be cracks. We call this as fissures. Fissures are cracks. You all imagine here? The hotspots can form two types of features. अगर ocean पे होगा, they form central vent volcanoes. They're like a pipe, eruption बाहर आ रहा है. अगर continents पे होगा, the cracks are linear cracks. Okay? सुन लो पहले. Okay, now listen. Now when the lava comes out, वो lava landform का कैसा shape होगा? So I have a central vent जहां से लावा निकल रहा है और एक क्रैक है जिससे लावा निकल रहा है. In central vent, can you imagine the lava comes in all directions almost symmetrically? तो यहां पर कैसा बनेगा आपका लैंडफॉर्म? The landform will be a conical mountain. In this case, when lava comes out, ये क्या बनने वाला है? It will be a sheet of lava coming out like a plateau. When from a crack, lava comes out and spreads like this. It will become sheets of lava. So on the continents, they form lava, basalt, plateaus. And यहाँ पर they'll form what's called as shield domal volcanic mountains. Both are formed because of hotspots, but they have different type of accumulations. So ocean floor will create this and continents will form this. Yes, correct. This is what is Deccan lava plateau. And this is what is Hawaiian Islands. Hawaiian Islands, Midway Islands, Emperor Seamount Chain, Reunion Islands, Mauritius Islands, these are ये वाले. Shield domal volcanic mountains. We also call them as volcanic shields. Shield क्या होता है हिंदी में? ढाल. Shield, remember shield? The shield कैसा होता है? A shield is gentle, sloping, massive. ऐसा होता है shield, right? ऐसे ही बनेगा. You will not have a steep mountain because lava is fluid, वो फैल जाएगा. This is a shield domal volcanic mountain. All done, all of you? Okay. So back to your notes यहाँ पर जो आप लिख रहे थे. Okay. So what type of landforms are formed? So they form fissure volcanoes on continents. They give us lava, basalt plateaus. or they form central vent domal volcanic mountains, also called as shield volcanic mountains, like Hawaiian Islands. Once you know some mechanisms ना, फिर उसके बाद you don't have to by heart too much. Understanding है तो आप apply कर लोगे. All done? So कुछ example उठाते हैं फिर. So examples of oceanic hotspots and the domal volcanic mountains or islands. Give me 4-5 names. Okay, Hawaiian Islands, Emperor Seamount Chain Islands, Midway Islands. Remember we talked about Galapagos? Galapagos Islands, yaad aa raha hai? I mentioned Reunion Island, Mauritius Island, Mauritius Islands. These are localized हैं. A very powerful one is also Azores Islands. Azores Islands in North Pacific. Galapagos is part of Ecuador. Azores is part of Portugal. Reunion is a French territory. Mauritius अपने आप country है. Okay, and these are naval bases of the US. World War II में if you have read about the Battle of Midway Islands, game वहीं change हुआ World War में. Japan lost their aircraft carriers in the Battle of the Midway Islands. Go back and read about it. There are 3 aircraft carriers. After the Hawaiian Island bombings के बाद में, when US had counterattack, the counterattack destroyed the naval fleet of Japan, and the battle is called as the Battle of Midway Islands. ये सब naval bases हैं US के on the Pacific. Yes, Midway battle. Yes, correct. हो गया आपका? Some examples of hotspots. Okay, and examples of lava plateau. Lava plateau continents पे होंगे. So the most famous that we know of is the Deccan lava plateau. Okay, we have Antrim plateau. Anybody knows ये कहाँ पर है? This is part of Australia. Antrim, A-N-T-R-I-M. No, sorry. Antrim plateau is, I think, Ireland. Antrim is Ireland. Please confirm this. I think it's Ireland. Then we have parts of Patagonia plateau, Argentina. Antrim is North Island, correct? Not Australia. Australia में है Kimberley plateau. ये नॉर्थ में है, नॉर्थ ऑस्ट्रेलिया, किम्बरली प्लेटो. यूएस में है कोलंबिया स्नेक रिवर प्लेटो. कोलंबिया स्नेक रिवर प्लेटो. 4-5 names are good enough. Location is under plate or above it. Abhirup, you're almost murdering me. Hotspot location कहाँ होगा? Okay, when I'm saying it is from deep mantle, okay, core border में आ रहा है, प्लेट तो बहुत ऊपर है बेटा. ये डाउट हुआ क्यों? हॉटस्पॉट प्लेट के ऊपर है कि बाहर है? I don't know, कुछ और सोच रहे हो शायद. Anybody else? Yes. कौन सा? Siberian plateau? No. It could have some parts, but Siberia is largely an exposed craton. कुछ parts हो सकते हैं. I'm not saying no. But the whole Siberia is not completely a lava plateau. Anybody else here? ठीक है? So what are the volcanism? What is the volcanism process? What type of lava formed and what are the associated landforms because of these lava? All good? कल संडे है, छुट्टी है. इतना लंबे संडे से आए हो आप लोग, दिवाली मनाते हैं और थोड़ा खींच लें. देखो हाथ जोड़ लिया इसने. हैप्पी दिवाली, यस. अब छठ पूजा वाला रेडी हो जाओ. Anatolia plateau is also an old craton. It doesn't have much of lava plateau. नो छठ पर छुट्टी वुट्टी नहीं है. छुट्टी है, क्लास में छुट्टी है. अब क्लास आएंगे, यहीं साथ मिलकर टेक्टोनिक्स में छुट्टी बनाएंगे. ठीक है, चलो ठीक है. वी स्टॉप हियर टुडे, कंटिन्यू ऑन मंडे. अच्छा, मंडे I might get 15-20 minutes late. Like, I might doesn't mean it will be late. I'll try my best to be on time, but just be prepared in case I'm late. Okay. ह्यूमन ज्योग्राफी भूल रहे हो, अच्छी बात है. ये तो मेरे लिए इकोनॉमी दिख रहा है. जितना भूलोगे वापस आओगे. ओके बेटा, अगर समरी नहीं बना रहे हो, ओके, ये गेम चलता रहेगा. ओके, हैप्पी वीकेंड फॉर ऑल ऑफ यू. कैच यू ऑन मंडे.